Hey, let's talk about variables.
Alright, so when we're working in any kind of environment, we talk about things. We use words to represent something. So if I talk to you about my car or my son, even though I'm only saying one word, a lot of information might come to your head. Talk about my car, you might think, well, how many doors does it have? How many tires does it have? Well, 4 tires probably. You might think about what its fuel economy is. There's a lot of information that could be packed into that one word, car. So we do the same thing in computer programs. We use a symbol or a word to represent other information. We call these things variables. Whoops, that's a W. Variables. All right, we also do this in math all the time. So in math class, you might see something like this. X equals 7. Then later, you could talk about a problem and say something like, well, what is 3 plus x? And you'd say, oh, well, that's easy. That's 10. Because x is not a letter in this case. It's a variable. It's referring to this piece of information up here. So that's the basic idea behind variables, and we do this in computer programming too, with a little teeny tiny bit of a change. So in math class, it's pretty much understood that you're always working with numbers. So x is always going to be 7. It wouldn't really make sense if I were to rewrite this and write x equals the word cat. First of all, 3 plus cat doesn't equal 10. Second of all, 3 plus cat doesn't make much sense. Now in a computer program, though, we work with more than just numbers. We might work with numbers or words or other things. So it's not as simple as just saying x is. We have to do a little bit more. So what we really have is 3 parts that are essential to making a variable in computer programming. 2 of the parts are already on the board. So one part is the name or the symbol that we use for the variable. In this case, x. Another part is the actual information or the data. So we'll call this data. So in this case, cat. So we have the name x, and then it is cat. The only other piece we need, for the computer's sake, because the computer gets confused otherwise, is to identify the type of information. And that comes first. So over here we want to write the word type. Now, in this case, the type of information we're dealing with is a word. Cat is text, it's in quotes, it's letters. In computer programming, there's different ways to say word or to communicate that you're going to be working with text to the computer. Specifically in the Java language, the way we do that is by saying x is a string. And really what that refers to is a string of letters, a couple letters in a row. So the type of information is a string, the name we're giving it is x, and the value or the data is cat. Now this is almost a complete line of code, but if we wanted to be syntactically correct, we would need to throw, at least in the Java language, a semicolon at the end of it. There's a string called x that has the value cat. Period. That's really a semicolon, but that's the end of the sentence. That's one statement. Let's try a couple more. So remember, we're going to do type, name, and information. Let's say I wanted to keep track of your age. Well, your age, a good name for that might be age. The type of information is a number. Now, usually you wouldn't say that your age is 17.3 or 18.9. You'd say you're either 17 or 18 or 19. So what you're working with there is integers. And integers are a very popular type of number to work with in computer programs. So much so that we have a specific type just for them, called int, I-N-T. Int age. Now, we could end this line of code right now. I could put a semicolon here, and this tells the computer that anytime I refer to age, I'm talking about a number. It says I don't know what the value is yet, but later on in the program, if I refer to age, it's an int we're talking about. So I could go to the next line if I wanted and say age equals 17. And that's perfectly acceptable. It's basically the same thing I did up here, but broken into 2 steps. Now, why might you do it this way? Well, maybe we don't know the information, we don't have the ability to type it in right away, so maybe instead of saying age equals 17, maybe you would do something like this. Age equals, and then we got to go get the number. So maybe we call a method. And remember, methods are just a little snippet of code that does something for us. So maybe we do something like this. Look up age on ID. So suppose I was the bouncer at a bar. You know, I wouldn't know people's age by default, but I would understand that my job is to check to make sure that people are at least 21 coming into the bar. So somebody might come into the bar, and the back of my head I'm thinking, what's their age? Well, I got to go find it, so I'm going to look it up on their ID. But this method better give me a number. In fact, it better give me an integer or there's going to be a problem. If I were to ask somebody their age and said age equals, what's your name? And they said Joe. I said, well, age can't be Joe. That doesn't make sense. So we need to have type agreement on either side of what's called an assignment operator, this equal sign. Right. So there's 2 different setups for declaring a variable and then using it further on. Hopefully that helps you get started with variables. Bye now.